Hello, my name is Colton from the University of Illinois Springfield, and today we're going to look at the spectroscopy of C7H14O2. Alright, so first we're going to look into the mass spec here. We looked at the mass was 130. We see that the graph length was 100. So the N plus was destroyed, which was fragmentized. So we will take our measurements from 130. So the base peak was found to be about 57, and we did the math. 130 minus 87 was 43, and we get the C4, H6, and C2 with a double bond to oxygen and a CH3 right here, which correlated to here, which 130 minus 87 was 43, 130 minus 75 was 55, which was nothing, and 130 minus 57 was 73, which was also nothing. So the only thing that popped up was this right here. And then we looked into the degrees of unsaturation formula, which was 2C plus 2 plus nitrogen minus hydrogens minus X over 2. So 2 times 7 plus 2 minus 14 over 2, which was found to be 1 for 1 double bond or ring.
So now we went to the IR region. It has 5 zones. Look at zone 1, there's nothing there. Zone 2 suggested a carboxylic acid or an alkane. We believed it to be an alkane. Zone 3, nothing, as you see, small line. Zone 4 went down very far, which suggested an ester or carbonyl. As we were told previously, we do have an ester in the group, so that's what we were going with. Zone 5 suggested an alkane, and we decided to go into the fingerprint region, and we actually looked at 1200 right here, this big loop. We found it to be an ester.
Alright, next we're looking at HNMR. So the integration numbers were 6, 3, 1, 2, and 2. So first we look over here, which we found to be a primary alkyl, which correlated to 6 hydrogens here with 2 CH3s, which integrated to this 6. Next we had 3 as a number for hydrogens, which correlates to this CH3 right here. Then we have the 1 down here at the bottom, which we found to be correlate to this 1 hydrogen off the carbon right there. And then this first 2 position we have right here at the CH2, which is to the right of this double bond oxygen and ether. So it's not as far downfield. And then this CH2 being right next to both of these 2 is pushed farther downfield, which correlates to this integration number of 2 for this CH2.
On carbon NMR, we're going to look at all the carbons in the molecule. So first off, we're starting with the least electronegative, which is 1, and it's right here, and we found it to be a primary alkyl, so that's why we circled here. 2, since it's so tall, we thought it would suggest 2 carbons in the molecule, and it also showed a primary alkyl, so we labeled it the 2 here, which would be, there would be hydrogens coming off there. Next, the 3, the line is thick here, which also suggests that this line represents 2 carbons, so we had to represent this carbon here, as long as this one here. 4, this one suggested that it could either be an ether or ester, but as we can find out, the next one is an ester, so we thought it would be the next closest to the ester in the molecule, so this 4 right here is that carbon. Lastly, the 5, the ester, right here, taking up this carbon.
This is Mason Kuhn closing it out from University of Illinois Springfield, and that about sums it up for spectroscopy.